It's good to see you, Sebastian. Welcome. I'm excited to be hosting today's Meet the Author event, and I'm joined by Sebastian Raschka, who is our author of Build an LLM from Scratch. I'm sure all of you know he is an LLM research engineer with over a decade of experience in artificial intelligence, and his book really takes readers under the hood of large language models, walking them step by step through what it really takes to build one yourself. It's a timely contribution to a space that's, of course, quickly evolving. And what makes today special is that we're joined not just by Sebastian, but also a few early readers of the book, readers who have been living with the content, experimenting with the code, and really forming their own perspectives. And so during this session, you're going to hear some of their questions. With that, let's dive in, Sebastian.
I wanted to say thanks for organizing this, Christina, and everyone also reading the book and all the feedback during the writing process and also afterward. To be honest, I think the readers really made also this book possible because I was starting this book, was writing it, and all the comments and feedback, it was super motivating, which actually helped me maybe finishing this faster or maybe even finishing it at all because I noticed, okay, people really are excited about this. So, and that got me excited. And I mean, I'm naturally excited about LLMs, but then also this really helped to have the patience to finish a book.
Let's first start by zooming out and exploring the why behind this book. So, Sebastian, let's look at some of the reader questions that are asking you to share your sort of broader thinking around the future of LLMs and what motivated you essentially to write this book. So, the first question that came in is, why did you write this book when few organizations were building LLMs from scratch?
One of the motivations was to really help people understand how LLMs really work. The questions said or suggested only very few companies are building their own LLMs. Whether you should or should not build an LLM, that's also a different question. I think with the book, I didn't, let's say, want to urge people necessarily to implement their own LLMs in production. It's fine to use existing LLMs like, even ChatGPT or other libraries like Hugging Face transformers. The motivation was more like understanding how LLMs work under the hood. There are a lot of resources out there, a lot of other explanations, but usually these resources, based on at the time when I started writing the book, they were more high level, showing figures, explaining things with analogies, but not really looking under the hood. And I think looking under the hood is really maybe the best way to understand how something works, to make sure you really understand the details. It's not just hand wavy explanations, it's really the real deal. And in that sense, the main motivation was understanding how things work. But that can apply to people who use LLMs. So, for example, if you never have to implement your own LLM, it's still useful because then you know about the shortcomings and you know, oh, they implement, or there's like the news article about the mixture of experts module and something like that. And it helps you understand what that is. For example, oh, this is, if you look at the article, then this is just replacing the feed forward neural network in the LLM. And I learned previously what that is. So I know exactly what, like where it is located and what it does, and if the hype is warranted or not, and these types of things where it really helps you keep up to date by having a fundamental understanding of how things work. And in some cases, it also does make a lot of sense to build your own LLM. For example, if you have smaller specialized applications where you don't need just a general chatbot, you maybe need something more specific, so you know how to fine tune the LLM. And there also, I've worked with companies who have restrictions. They can't just use ChatGPT, for example, because they have sensitive data. And so the book is, in a sense, it's not building the production ready LLM because it's a very small LLM so that it works on laptops for illustration purposes. When I was in school, we were allowed to use calculators, but we still had to learn math because the availability of the calculator doesn't replace the need for learning math. And in that sense, the fact that ChatGPT is available doesn't replace the need to understand things, basically. So if that makes sense, yeah. So, and the book was hopefully helping people to look behind the curtain and understand things. Maybe the last thing also is just comes to my mind as a researcher. If you want to advance LLMs, you have to start somewhere, right? Even if you join a company like OpenAI, you have to learn about LLMs at some point to build the next LLM. And in that sense, I hope the book is also useful as like the foundation for that. Yeah.
Yeah.
Long answer, but I hope that addresses the point a bit. Yeah.
Another question that we received was, how would you advise readers to tackle the book? given the complexity in later chapters, in particular chapters 5, 6, and beyond?
Yeah, I always thought chapter 3 was the most complicated one, the attention mechanism, because you can start like top down or bottom up. Top down, like just using an LLM and then explaining the details, or bottom up, really making sure you understand the building block before advancing to the bigger concept. In that book, it was more like a bottom up, where we started with the attention mechanism after the data loaders, where it's more like building the motor of the car before even explaining what the car is. So the reason why I structured it like that is otherwise there would have been a chapter that implements the whole LLM to use it, and that would be kind of or not complicated, but kind of confusing. You have this whole code, but then you don't use or explain all of it until later. So in that case, I decided to build it bottom up. I thought honestly chapter 3 was the most complicated one, the attention mechanism, but you mentioned 5, 6, and 7. And I would still so to answer the question how to approach it, I would still do it sequentially as a reader, like going through the chapters sequentially. And of course, yeah, it gets maybe a bit more complicated, as some people may have pointed out then. How I would approach this is still one step at a time. Maybe I think the best way is to really copy the code into your own code notebook. And sometimes I do that with other resources. Typing it myself helps. When you type something, you think about it differently instead of just copying. It's a lot of work, but it's also worthwhile sometimes. So it's like a good way to learn. Again, in school back then, I don't know if people learn differently now, but I remember in fifth, sixth grade, we had to, so the teacher was reading a text from a book and we had to write it down. And then we had to hand it in and to see the teacher wanted to see if we know how punctuation works and spelling and stuff like that. And I think this helped more than just reading a book, because I was reading books for at that point maybe 10 years already. I still made a lot of mistakes, but then when you think about it and you write down the text yourself, it kind of you think about it a bit more deeply. You are more conscious about, oh, should there be a comma or not? In that sense, I think for the book, also if you copy the code, it works and you get to the results faster. But if you type it when you are, especially when you are not sure how something works, it helps you maybe to slow down and think about things. And maybe that's one advice I could give.
Another question that came in is, what is your opinion on the future of large language models?
I would say they are here right now and they're very useful. So people use LLMs for all kinds of things, from writing email, writing code, answering questions. And I think this will be around for a long time. So we will have LLMs for, I would say, at least a few years. I'm saying not maybe forever, because there might be a more efficient way of doing things one day, but we don't know what that thing is. So we will see. So it's just speculating. It's the same as saying cars won't be around for forever. So back then, when they invented cars, I think in maybe 1920, I'm just making this up, but around that time, people were thinking, oh, this is a new thing. And then maybe 10, 20 years later, they were more like becoming more popular. And at that point, one could have said, okay, they might not be around forever. It turns out they are still around. They have evolved though. We have now electric cars in addition to traditional cars. And in that sense, I think also with LLMs, they might evolve, but the need for something like this, I don't think it would go away, because why wouldn't we want to have something that can help us with things? Like, I can't see them going away. I can see them becoming more efficient and evolving. Maybe they get replaced by something better, but it's like, yes, it's hard to say when, because no one knows. So I think they have quite the future ahead of them.
Do you think they will become commoditized?
We see that already with applications. So there used to be just ChatGPT and maybe Google Gemini, and now it wasn't even called Gemini, it was called Bard, I think, back then. And now there are many, many more companies offering LLMs, not on that scale as Google, OpenAI, and Anthropic do, but many more people use, or companies offer, smaller LLMs. And I think what we will see is also more special purpose LLMs, that more companies fine-tune LLMs for specific applications, because right now a lot of them are special purpose, like general chatbots. Yeah, I can see the commoditization in the sense that more companies will have their own LLMs for their own needs. I mean, LLMs to some extent are already embedded in devices like iPhones and so forth. Maybe not the best LLMs, but they are there. and I think they will also improve. And so in that sense, I can see LLM being a commodity that they will be very uh, much embedded in a lot of devices. They will be around. People will probably even stop thinking about LLMs as a model, but more like a spell check. So, for example, when we use any software on our computer, there's usually a spell check built in. It's either by the operating system or by the application. And we don't even think about what model does the spell checking. And I think maybe similarly with LLMs, we will have just an integration that tightly into tools that we don't think about it as LLM, but we will think of it as a code assistant, as the question answer, like or a summarization tool. It's just like a software embedded improvement to whatever we are working on. So I can see that being developing in that direction. Yeah.
I could see that as well. Do you think that a lot of organizations will eventually invest in small language models?
I think it will take time because it requires money and also a bit of talent, like in terms of hiring people who can implement them. Small LLMs are, I would say personally, only useful if they are specialized. Because if you have a larger LLM, they are more general. Usually, something like ChatGPT is a very capable model on a variety of fronts. It's more like a general purpose model. It can do a lot of things. You can be better than that if you are specific with a small model, but that requires that you have data and examples to develop it in terms of training and fine tuning it. And I think there will be plenty of organizations who want to do that to save also money, especially if you're a big company. You have probably a lot of data. You have maybe a lot of people who have some experience. You can say, okay, maybe help developing this model like it's an R&D effort and see if that can match the performance of a bigger model in a specific task, and then also how much money does it save us. And right now I think we are living also in that time where LLMs are very relatively cheap. I think it's just speculation, but I think it's very heavily subsidized to get people to adopt LLMs. And I can see LLMs becoming more expensive over time. It's almost like, internet or phone plans, they haven't really become cheaper over time. And I can see that same also happening to LLMs. And at some point, it would make sense to invest in your own LLMs to basically save money. It's kind of like related to cloud computing. When you're a new company, a small company, you usually start off with renting GPUs or in like cloud compute because it's expensive to build your own data center. And but it costs more later on if you have a larger company. You pay like a markup because the company providing the cloud compute has to make money also, and there are more people involved and so forth. And so if the company reaches a certain size, it might make sense to build their own data center and hire people who take care of the data center. And I can see the same thing also with small LLMs. There's a certain threshold where it might make sense to invest in small LLMs. But it's not, I would say, yes or no. It's more like a spectrum where people will probably, depending on the task, transition to a small LLM. Yeah.
That makes sense. Now that we've kind of covered the big picture, let's get into the sort of mechanics of it. With these next few questions from readers, let's talk about the sort of technical skills, challenges, and architectural decisions that are involved in building a large language model from the ground up. This first question is asking, what are the most important skills for creating, updating, and maintaining LLMs?
The skills involved in like updating, maintaining LLMs is similar to almost like maintaining and updating software systems, or yeah, it's also related to in general classic machine learning where there are multiple things going on. So models need to be updated, and for that it needs to be very principled, where you want to measure whether your updating makes the model better or worse compared to the previous model. And so for that, the most important skill I would say is having a good way to evaluate and test things, to have like a good framework, a very organized, let's say, toolkit that you might adopt or develop yourself to make sure that changes don't break anything. Especially with LLMs, it's very tricky because they're not very, they're not deterministic in the sense that the way we use them, we usually have random sampling, and so forth, and they might generate different responses sometimes. And they're not like, like a calculator. They're not that reliable, where you always, if you type 5 times 4, you always get 20. In LLMs, you might get sometimes 200, 21, 19, or something like that. So it is a bit trickier to test LLMs, but still it's important to have at least like the benchmarks implemented in a way that you can run before and after comparisons and look at the average performance and monitor drift or things that you might care about for your business. So I think that's the most important skill, to really make sure you know how to evaluate things, if that makes sense. Yeah. And then also one more thing is maybe keeping up with recent literature, to keep an eye on what is out there, what are other people using, and should I switch or not, to recognize, okay, mine is okay, or maybe I should try something else.
Do you think that large language models will ever update themselves?
That's a good question. I think it's hard to say. I don't think it's impossible, but I don't think it will happen very soon. I think right now we're at the stage where you still need a lot of human supervision to especially evaluate LLMs. Yeah, you could automate that. Actually, for a lot of benchmarks nowadays, people use other LLMs to evaluate LLMs. So, in that sense, one could think about chaining together a system that modifies the architecture and then runs the benchmarks, and then maybe collects more data, fixes things, and then implementing a loop like that. I think it's technically possible, but it's also pretty brittle. We are just in the early stages of these agentic workflows, where something like that does work okay, but it's not very mature yet. So I would say ever. I would say maybe one day. I think it's possible, but it's maybe not the best way right now. It would not also be making sense, I think, even like resource-wise, because you probably have to do there's more trial and error compared to an experienced person who knows already certain things. So I think possible, but maybe not soon. Yeah.
From your perspective, what was the hardest or most surprising part of building an LLM from scratch?
I would say that was the loading of the pre-trained weights. There are many different ways you can implement an LLM architecture that works and trains very well. It's like the saying that all roads lead to Rome. There are multiple ways you can implement an LLM architecture that is not necessarily wrong and that would just work fine. And maybe there are even things you might do to make it better that others have not been doing. But if you want to load the pre-trained weights, you have to match the other architecture. Exactly. That was maybe the most challenging part, because I had to go back to the TensorFlow code because in chapter 5, we loaded the GPT-2 weights from OpenAI, and they back then implemented GPT-2 in TensorFlow. So I had to go back into TensorFlow and make sure my implementation exactly in PyTorch matches the TensorFlow implementation. With that, I mean, they used, for example, bias units in the QKV computation, which is not standard. And I think they just did that. I don't know why, because maybe it was the default setting in TensorFlow and they didn't think about it that much, in terms of they just kept the default setting. And then that was something you had to make sure you also do. And I think there was something in the RMS norm. No, I think that was the GELU activation. So there are multiple ways you can compute the GELU activation, and they used an approximated way. And I think they did that because it was computationally cheaper back then. And you have to match that, because otherwise you get small discrepancies when you run your model. The model might generate sometimes gibberish. And so you have to be very careful to get the exact numeric implementation right, even like small rounding errors and stuff like that. And I think that was the main challenge. But if you train a model from scratch yourself, that wouldn't matter that much. Either model would work fine, especially because nowadays LLM papers are not very detailed. They're more a big picture. And sometimes these details are not shared. And then you have to kind of like, yeah, Sherlock Holmes, go in there, think about possible explanations, try it out, and oh, this makes sense. It doesn't make sense. Or it's like a trial and error also almost. Yeah. That was maybe the most challenging part.
And what's one part of a large language model that you would say people often will overlook?
I would say maybe that LLMs are still deep neural networks, because we talk about LLMs as, I mean, it's its own type of model, but it's still a deep neural network. And in that sense, what's nice about it is still the same concepts that applied 10 years ago when we were building RNNs and convolutional networks. we still use the cross entropy loss for training. And I think this is often overlooked, that we don't talk about LLMs as deep neural networks. And they're still deep neural networks. We can reuse a lot of the same concepts, like the optimization algorithms, the normalization layers. It's, yeah, I think the only thing that is really different is we have the attention mechanism that is not present in other architectures, except the transformer architecture. But other than that, yeah, it helps to think about LLMs as deep neural networks. Yeah, that's maybe something that is often not talked about. Yeah.
Sure. Did you explore alternatives to transformers?
Yes and no. So for the book, no, because I wanted to help people understand how LLMs work. And the current generation of LLMs, they are all transformer-based LLMs. And so transformers are, I would say, right now the most capable approach for large language models, but there are also other ones. I read papers occasionally about alternatives, especially state space models. For example, there is Mamba. There's also Samba and Jamba. And so lots of interesting terms. So the state space models are like an alternative to the transformer. And some of them, like Samba and Jamba, they also have attention layers. They are basically hybrids. They are interesting, and I think it's good that people experiment with those. And some people, I think, even train them on like a 8 billion parameter scale, which is not huge, but it's relatively big. They are quite capable, but no one knows yet, I think, how they would compare to something like ChatGPT level LLM, like something that is really large scale. Because they do very well on benchmarks. For example, when we look at the benchmarks, they do very well on MMLU, I think, which is more like question answering. But the benchmarks don't really, based on my knowledge, they don't test conversational skills. So with that, I mean, when you have something like ChatGPT, you can type free-form text and it gives you free-form answers. And MMLU, for example, is more like multiple choice question answering. And so knowledge-wise, so in that sense, they work well. We would have to know how well a system works if it has been trained on a scale of maybe 15 trillion tokens, 200 billion parameters at least, to make a comparison. And then maybe we can tell more if they are promising. It's just speculating, but it's not clear. I mean, these models work well on a small scale. So let's say up to 8 billion, they rival other models like Llama 3, 8 billion. But we don't know what happens afterwards. Maybe they saturate. Maybe they go like from 1 billion to 8 billion linearly, they improve. But then there is like a cliff where they just stop improving after a certain size. And so no one, as far as I know, has explored that yet. So I would say they are interesting and it's really cool that people are working on those. But I don't know if they will be like the future. We will see. Yeah.
We will see. And another reader wants to know, is there a plan to fine tune the book as new techniques emerge?
It sounds like updating the book.
Yes.
So yeah, so with the book, I try to keep it foundational, if that makes sense. I read a lot of papers, multiple papers a week. I keep up to date with things, implement things, but I didn't want to cram it all into the book because most of it is very short-lived, where it's maybe an interesting, even LoRa, to be honest. So I have LoRa, it stands for low rank adaptation. It still is a very popular technique that came out 3 years ago. Last year, it was a very popular topic. And now this year, I don't see much LoRa anymore. I mean, there are people still use it. It's very useful at companies where people fine-tune LMs for special purpose applications, but I feel like tapering off. And I'm glad that I included it in the book, but I don't know if it will be still a foundational topic in 3 years or 5 years. Maybe there's no need anymore. So I try to avoid putting too many research trends into the book. I have a blog where I write about those. So where the blog is more like, what are the most interesting techniques of the month or of this quarter, where it might be relevant now, but it might be outdated in half a year. Maybe it's even a bad idea to recommend these things in a year from now. And so in the book, I try to avoid covering too recent methods because you don't know if they stand the test of time. And so the book is more like the foundation. So when you understand, for example, how the GPT-2 model works, it's not the latest LLM, but it will help you understand how other models work. So for example, in the bonus section, I implemented also Llama 2 and 3. So that required updating attention to grouped query attention. And there were some other modifications, for example, replacing layer norm with RMS norm and with absolute position embeddings with rope rotational positional embeddings. And in that sense, It was quite, I mean, it's quite easy to follow if you already know the base architecture, because the base architecture is still the same. For the book, that was my motivation to have the fundamental base architecture, and then later on there can be add-ons to explain newer things. And so there is no immediate plan to update the book. Actually, I couldn't even update it in a sense where I just mentioned, like, for example, Llama replaced layer norm with RMS norm. If I would go in there and replace that in this architecture in the book, we wouldn't be able to work with the pre-trained weights anymore. So it's like a domino effect. You change one thing, the rest won't work anymore. And so I wasn't planning on tweaking things as new research comes out, but I'm hoping maybe every 2 or 3 years to update the book as a whole, where maybe instead of GPT-2, it would make sense to use the Llama model. But I don't know. It depends. We will see when the time comes. Because one challenge also is that even the smallest Llama 3 model right now is 1 billion parameters. And that would be harder to run on a laptop. And that would require people to use GPUs. And it's possible and it's a good idea to use GPUs, but it would make the learning harder. Like, if you want to just get started, it would put more hurdles in your way because now you need a GPU. Of course, it's a good skill to, at some point, learn how to use a GPU, like a cloud GPU, for example, but that might be even a different book, like a sequel, if that makes sense, where maybe it's a good idea to keep the book foundational and then have a sequel, like a follow-up book that covers other topics.
Let's look at some of the practical choices that were made during development, like language and framework selection. Many of our readers are asking as they start to experiment this themselves. The first question that came in was, why Python over Rust or C++?
I know C++. That was one of the first languages I learned. I know Rust. I can program in Rust. So Python is naturally easier. But also, it's easier to teach someone in Python than in Rust and C++ because it's a bit more human readable, less verbose. But that was not the reason. I think it's like a benefit that it is easier to read. But the downside of Python is it's very inefficient for scientific computing. So if you look at it as a whole, if you are a researcher or an engineer, and you have, let's say, 20 hours to accomplish a task. If you write something in C++, you may only get half of the task done because it takes a lot of time, for me at least, to write C++ compared to Python. But the code that you get will run faster. So in the long run, it will pay off to use to use C++. But in the short term, if you just want to get a prototype done, Python is just faster to write and you get results. But then in the long term, yeah, it's going to be slower and more expensive because, I don't know, it takes 10 times to run the same code if you have it already implemented. For the book, the goal was not implementing the most efficient LLM. It was about explaining the LLM. So Python is a bit easier to read. More people, for sure, more people know Python, making it more accessible. But then also because PyTorch, the main deep learning library, the most widely used deep learning library, is implemented in Python or has a Python API. And under the hood, it uses CUDA kernels or CUDA code. It's like C++ for the GPUs. But you as the user, you don't have to worry about it. You just use the Python interface. And then under the hood, it manages that. Sure, it could be more efficient if you just implement things in pure CUDA, but that would be really hard, especially for a beginner. Even for experienced engineers, it's very hard. So how it in practice usually works is people start with PyTorch, even like experienced teams, even at Meta, they use a PyTorch, implement the LLM, train it for a few rounds, see that the LLM works because PyTorch is just easier to debug, easier to read and everything than, let's say, pure CUDA code. But then they go in and, oh, it works, it's great. How can we make it a bit faster? And then they would fuse some CUDA kernels, make a few optimizations here and there, and see if it makes it faster, because then you will save money in the long run. So they customize basically their PyTorch implementation. But I would say 99% of the teams today would start with PyTorch, get the prototype working, and then optimizing later. So there was actually one reader who shared a GitHub repository with me, who took the GitHub repository from the book and re-implemented this in Rust. I think he used a Hugging Face library based on Rust. I think it's called Candle. So it is possible for sure, but I think it's not the most common approach, let's say. But one little tidbit is also that in chapter 2, the tick tokenizer, it's a tokenization method that we're using. We are using it through the Python interface, but also under the hood, it is using Rust, basically. So Rust is kind of right now replacing code everywhere, but the interface is still Python. That's like the long story here that Python was just the more natural choice, more readable, but it's also what's most commonly used to implement LLMs before doing optimizations. Yeah.
And another reader was wondering, could it be rewritten in Rust or ML.NET? And of course, you started answering that. Yeah.
Yeah, coincidentally, yeah, we just talked about there was a reader, yeah, who did implement it in Rust. I haven't really read through this in detail because I'm not a Rust coder. It was using the Candle framework, which I think is an abstraction on top of Rust. But if you can implement it in an abstraction, you can also remove the abstraction. So yeah, it would be possible to do that in Rust. Unfortunately, I have no experience with ML.NET, so I can't say anything about that.
And Sebastian, should people learn how LLMs work under the hood or just use tools like Hugging Face? What's your opinion?
You can actually even start with Hugging Face transformers and then learn later how LLMs work under the hood, or you can do it the other way around. But I do think it is very helpful to understand how LLMs work under the hood, even if you plan to use Hugging Face transformers. Actually, I think it's a great library, and I would also recommend people to use established libraries like Olama, maybe LM Studio, Hugging Face transformers for inference in production. Because why not? They are tested by many people, they are optimized. But in addition, it does make sense to learn how to implement an LLM just for the sake of understanding what you are using there. I think it's always a good practice. For me, also, that's how I grew up. I always wanted to understand how things work. Okay, it's like a little tangent, but I was watching Formula One as a kid. There was a German race driver, Michael Schumacher, and he grew up working on karts. So he was most Formula One drivers I heard they start with go-karts before they get into the faster karts. And he was a very good race driver. I mean, partly because as a kid, he fixed the go-kart and tweaked the go-kart and so forth. So he had a better understanding of how cars or go-karts work. And that kind of transferred also to the Formula One car. So he could give more targeted advice to the engineers and say, hey, something doesn't feel right there, or maybe try to tweak this. And that helped getting more performance out of the car. And I can see the same thing here too, where even though you might be using Hugging Face transformers, it might help to understand how the LLMs work under the hood, because then it helps you understand certain shortcomings, things you can try, and so forth.
I agree. Looking ahead, things are obviously evolving fast from transformer models to the rise of large concept models. So let's shift our focus to the future and talk about sort of the trends and use cases you see on the horizon. One question that came in was, how do you think large language models will change in 5 years or even 10? And I suppose that's pretty far out to try to
Yeah.
speculate.
We have seen in the last few years, datasets became bigger and models became bigger. But then with the release of GPT 4.5, we saw that this started saturating. GPT 4.5 is great, but I think there was like diminishing returns in terms of how the modeling performance jump was compared to the resources that went into it. Of course, it's not public knowledge how many resources went into it. In that sense, I can see that the focus shifts more towards algorithmic improvements rather than scale improvements. I think we are not quite at the point where it fully saturates, but I think we will probably see a more efficient attention mechanisms, but also there's a move towards alternatives like Mamba and so forth. They look promising, but if they will really replace LLMs, we don't know yet. Maybe we won't even call them LLMs anymore. Maybe we'll call them GLMs, like general language models. I don't know. Maybe there's no large in the large language models anymore. So hard to say. But right now, I think they still have like a few years at least ahead of them, where we still see people or companies making so much progress. I mean, just the recent releases with O1, O3, Sonnet 3.7, the new Google Gemini Pro 2.5. The jumps are so good that it would be unwise to abandon LLMs. So I think they still have a future ahead where people currently make them more efficient. So a mixture of expert modules for the reasoning models, replacing the PPO with a GRPO because that is more efficient. You remove the critic model. Like it's all about efficiency tweaks for now. And so we will see in 5 to 10 years if that's still largely the same architecture. Could be, because if we zoom back, for example, the GPT-2 model that I implemented in the book, It's already 7 years old. So it was implemented originally in 2018. That's 7 years. So and still it's very, very relevant. It's still the foundational architecture of these other LMs. I mean, of course, people changed little things inside, but fundamentally it's still the same architecture. And so it could well be that in 5 years we still have the same architecture, hard to say. Yeah.
And another question asks, what's the deal with large concept models versus token level LLMs?
Most LLMs are right now token level LLMs, which means they are predicting one token at a time. And large concept models, as a concept, it's almost like a sentence, like some connection of words that have convey a meaning when they are occurring together, compared to just looking at one word at a time. Right now, I think this is something people explore in parallel, but I'm not that deep into the literature there. So right now, I would still say the token level LMs that we have, they are the best thing we have right now. Everything else remains to be seen whether that works at the same scale. Because LLMs, the usefulness, the fact that they work so well, it just comes from the scale. If we take a very small LLM, even the one in the book, it's relatively unimpressive. It works, but the fact that they work so well is really just happening at the scale. And so if we have large concept models, even if they might be promising on a small scale, we will have to see if that's still the case when we on the larger scale. Sure, the larger the scale, the better the models will become as well. But whether they will still compare favorably to large LLMs, the token level LLMs, that is something that we would have to see once we have LLMs that size. And I think one good hallmark or like a good guidance here is really what are the biggest companies with the biggest budgets doing. The biggest companies in the LLM space are OpenAI mainly, Google and Anthropic. And the most, I would say, impressive LLMs are Sonnet 3.7, GPT 4.5, and o3. And then also from Google, the Gemini 2.5 Pro. And they're all still token level transformer based LLMs as far as we know. And I think if there was something better, they would have been replaced already by that better thing. It's definitely worthwhile doing R&D on other things, but nothing has replaced things yet. Yeah.
What emerging use cases are you most excited about?
There are lots of special purpose use cases. I was a computational biologist 10 years ago. I think that's very exciting to see LLMs being used for making scientific discoveries, or not even making discoveries, but helping in the process of making discoveries, just making the work easier. Even AlphaFold, for example, is transformer based. So I think also beyond just LLMs, the transformer architecture is very useful. Like the learnings we have from LLMs, if we scale things up, we can do cool things with it. But beyond that, I would say, because I don't work in computational biology anymore, I feel like for me, the most exciting thing right now is code assistance. So I use LLMs for coding in moderation. I don't use any IDE that is purely like LLM based, for example, like fully automate my coding. What I do is that I take my code, paste it sometimes in an LLM and say, hey, do you have any suggestions how I can make that more efficient? Or if I have a bug, I ask the LLM to help me finding the bug faster. And so I feel like this is actually very useful to me where I have someone or something where I can bounce ideas off of, where it's sometimes it's more like brainstorming. It sometimes helps me see something I don't see myself. It's very trivial maybe, but I think that's something I'm mostly excited about. I'm not excited about what LLMs replacing anything I'm doing. I'm excited about LLMs helping me with what I'm currently doing. How does it get me to the next level? How does it help me becoming better at certain things I'm already doing, basically? Yeah.
And so, just out of curiosity, in your vibe coding, what LLMs do you use?
I actually use mostly ChatGPT LLMs. Last week I started using 4 Mini High, the new reasoning model from OpenAI. I must say it works okay. I like it, but they're still not perfect. Sometimes it gives me useful results, sometimes not. I used also o3, but I got rate limited in terms of I was using it too much. So I have to wait a few weeks or days or weeks or something like that. So I was using mostly o4. I should sometimes explore other providers too, because I think they're all good. And I heard Sonnet 3.7 is currently the best in coding. That's what my colleagues tell me.
There are some subscriptions that will allow you to toggle between LLMs as well, I
Yeah,
think.
yeah.
So, to sort of wrap up this moderated discussion, Sebastian, I'll ask you to share just a few learning resources with us, especially for those who want to go deeper into data structures and algorithms that power these models. We got that very question in. A reader asked, are there any foundational data structure and algorithms books that you personally would recommend for readers who want to go deeper?
Good question. It's been a while since I was in college and since I learned about data structures and algorithms. I forgot the textbook we used, but a long time also ago, I interviewed at Google. I ultimately decided to stay in academia back then. The interview was successful, so I think the book I used was also a good book because otherwise maybe the interview wouldn't have gone so well. It's really a coincidence, but I do think it was a Manning book. And it was something with grokking, either grokking data structures or grokking algorithms. And so if it was updated, or even if it wasn't updated, I think it was still a very foundational book where it covered all the foundation algorithms and data structures. So that might be one to recommend, but you might know more about that than I do.
We do. We have both grokking titles. Well, I think we cycled through all of the questions from the readers today. So I just want to thank you, Sebastian, and of course, all the readers for joining us today. This was a thoughtful and inspiring conversation. It's been fascinating to hear your insights, Sebastian, not just about the technical nuts and bolts of LLMs, but also about just the bigger picture and where this technology is heading into the future. For anyone on this call, if today's discussion kind of sparked your curiosity, I encourage you to read more at manning.com. So thank you all.
Yeah, thank you everyone for joining and for the good questions. It was actually a really nice selection of questions. And also thanks, Christina, for organizing this. It was actually quite fun. And if there are more questions, there's always the Manning Forum. I'm always happy to answer questions there too. Thanks everyone for joining.
Get this book at manning.com.